doing this recording right now, we are in the middle of a lesson.
Are we? How many more days until we have to be together?
7.
You're gonna hate me for baseball
What else is a quantity? So it could be an amount, one number, right? The quantity in a bucket, right? What else is a quantity? We've talked about this before. In algebra, a quantity could be considered what? Please? Maybe. But in algebra, a quantity could be something like x plus 2, where we put parentheses around it. Remember that? Talked about that before. Okay? So, a comparison between two numbers. How are ratios shown? How do you write a ratio? As a fraction is probably the most important, right? Shown as a fraction. So we'd say A over B, for instance. Any quantity A over quantity B. Any idea how else I could show that? I can also use a colon, A to B, or I can actually use the word to. Okay. Now when you write this simple ratio, you want to make sure that you always go by how they give it to you in the problem. So when they say, I want you to compare A to B, A has to be on the top or first. If they would say B to A, then we would just flip-flop everything. But that's really important. And then always make sure that we want to do what? What have we always said when we're dealing with fractions?
Reduce.
Always reduce. So we always want to make our fraction as small as we possibly can. Okay? Now remember, we can write it the other way. We're just describing the situation in the opposite way. So we could write a ratio in this class for the number of boys to girls. Right? So that fraction could be a number over itself, but then we could flip-flop it and say the girls to the boys. But in either way, in that case, what do we get? Alright, so we have 4 over 6 or 6 over 4, depending on how they say it in the problem. Do we want to do the girls to the boys or the boys to the girls? Okay? And you want me to just do it for you too? Alright. So, okay with that? The next part right here is really important. So we want to do this then, if we're comparing measurements. That's kind of what we are, the reason we did the problems in the review that we did. Those were measurements, right? When you compare measurements with ratios, the most important thing is to turn everything into the same quantity. And again, that's why, as I said, we looked at some of those. in our bell ring. Again, now, if you have problems with some of this, don't forget it. There's a bunch of conversions in the back of your book, way in that back cover, that'll help you out with some of those things. Okay, so basically what we're saying is we want inches to inches, not inches to feet, and so on and so forth. So if they say express the ratio of 10 roses out of 12 flowers, now here's the difference, okay? If you think about roses to flowers, they're just what? It's still a flower no matter what we really think about it. It's just a more specific flower, right? So in this case, when we're talking about these measurements, we're talking about those lengths or those widths, those things that we can actually measure. All right? The centimeters, the inches, the cups, those kind of things. That's when we want to make sure of this. Here, when we're talking about the ratio of 10 roses out of 12 flowers, it's still flowers. We're just writing it in that same, or in a different order. So in our case here, if we wanted to express the ratio of 10 roses out of 12 flowers, we're going to write what fraction? 10 to 12 and then reduce, or we just jump straight to 5 to 6. So basically, what is it saying? Out of every 6 flowers, 5 of them should be roses. That's what that ratio is saying, okay? But then the next one is the one that we want to concentrate on. If we want to write the ratio of 21 inches to 2 yards. Now this is where we got to be careful. Now here's where you got to think a little bit. Would I rather turn inches into yards or yards into inches? Do I know how many inches are in a yard, or do I know how many yards are in an inch? I know more inches into a yard, right? I could probably figure out how many yards are in an inch, but how many yards are in an inch, then I'm going to have to deal with what? Decimals or fractions, and we don't like that, right? We don't like sometimes regular numbers. So let's do inches. How many inches are in 1 yard? 36, right? So if we have 2, we're going to say what? 72. And then the last thing that we have to do is what? See if we can reduce. Can we reduce?
Yeah.
What can I take out of both of those? 21 divided by 3. 72 divided by 3. 9 times 3.
24.
24. How about now?
No.
Now we're done. So basically we're then 7 over 24 inches. Right? Okay. How about this one? Kind of trying to trick you here in this last example. A class consists of 12 girls and 16 boys. Express the ratio of boys to the total number of students. Now we'd say what?
16 boys to
16 to 28, and then we would try to reduce, right? What can we reduce by? 2 definitely. Anything bigger? 4. 16 divided by 4? 28 divided by 4?
7.
So again, if you would have used 2 twice, you should have still got to 4 sevens. But again, if you use the bigger number, then you only have to do it once. Okay, so again, notice here in this one, when we're talking about boys and girls, yeah, we really can't convert a boy into a girl. Technically, you probably can, but we're not going to have surgery in the middle of a math class to figure out that, right? Okay? So, when you're talking about girls and boys, for the most part, you're talking about human beings. But we know that not in all math classes are we always dealing with humans either.
He's not
Yeah,
alien. He's like an alien.
Yeah, I know. I thought you already said you were.
No, he's
Yeah,
the
you're-
alien.
That was your.
You literally said like 2 classes in a row that you're an alien, and you
Yeah, and you have a train that is like a rocket ship.
Rogue One? Remember?
Oh yeah, you missed that one.
Yeah, you missed that.
I wish I was here now.
Oh, no you don't. Because we all got dumber then.
He asked me for a Kolak answer, and like, I gave him a Kolak answer. That's what it was.
Unfortunately, yeah, it was my fault. So the next thing, are we good with that? Those are basic ratios. We'll use those tomorrow especially. The next thing we talk about is a rate. What's a rate?
How fast we're going.
Okay. What else is a rate?
Consistency?
Okay. Yeah, but what are you talking about if you're talking about how fast we're moving?
Speed.
Okay, speed. And how would we measure that? Miles per hour?
How long?
Okay. How else might we say a rate?
Kilometers per hour.
Okay. How else?
Miles per second.
Miles per second, maybe. You probably haven't gotten into a whole lot of science stuff yet. But in science, what's gravity measured in? You know that one?
I know this one.
Not miles per second, but
Meters per second.
how much?
Meters.
There you go. Meters per second. Okay. So, what do you notice here when we're talking about a rate?
Hours.
It's
Time.
It's
Basically, a rate is still a ratio of measurements but now we're going to have different units. So in the first part, we were talking about ratios and converting them all into the same thing so we could compare them. Now we're going to look at them with different units. And this is where we get a rate. So anytime you hear a ratio needs to be consistent, meaning it has to be the same on the top and the bottom. When it's a rate, you're automatically going to be comparing, in a sense, two different things, okay? So you're always going to have a rate where it's going to be something over something else. Does that make sense? Okay, so the challenge then is to do a conversion factor or converting rates. All right? And this is where it's really important that you use that little section in the back of your book to look at all those conversion rates and understand them. So when we're going to do this, we're going to try to convert rates. So we're going to change them from one something or another to something else using math. All right, so when you convert rates, you're going to set up fractions with multiplication. Now this is what we just got done doing and taking the test over, right? That was a part of the test, multiplying fractions. What was true about the first thing that we tried to do when we were multiplying fractions? Before we actually did our multiplication, what did we try to do? Reduce or simplify. In what directions can I simplify? Diagonally or up and down, okay? So, when you're setting up these fractions, this is really key to the whole thing, is that the same unit or units need to be diagonal from each other. And why? Because we actually want the units to cancel each other out. All right? So if they're diagonal, they're going to cancel each other out, and then whatever's left over should be what we wanted to get to in the original problem. So they're going to tell us, hey, take miles per hour and convert it into minutes per second. Okay? So minutes and hours, miles and you could do those conversion rates. And you could go through and look at them. Or we'd say miles per hour to feet per second, probably. So we're taking miles and changing them into feet. We're taking hours and changing them into seconds. So you might have to do multiple conversions in one problem. Now we're going to start out pretty simple, but when you take chemistry, for instance, this would be a huge thing that you would do a lot of in chemistry and physics. So those of you that want to get into like engineering, you would like converting stuff. Okay? So this is going to be something that's really important that you follow what we're looking at. So again, 718, 721, way in the back of the book is your conversions to help you out. All right? And so then, again, we're setting up a multiplication problem with fractions. All right, so here we go. Let's look at one. A snail moved 30 feet in 2 hours. How many inches per minute did the snail move? So again, now, probably you can look at this or these problems today, and you can probably do it in your head. But down the line, you're going to have to actually do a math problem with it, so it's probably good to actually learn the process. All right, so when you read the problem, write it out, and show yourself what you have. So I have 30 feet per 2 hours. All right, so that's my first fraction. That's my rate, right? Feet per hour. Now, obviously, this is some people that we know, right? Even a snail might beat some of us in a race. So, right? Okay. So, what are we going to turn it into? Inches per what? All right, so this is what I would do. And this is totally up to you, but I'm going to show myself then what I'm going to turn it into. So now, I'm going to try to go from here to over there. So my next fraction that I'm going to set up has to be some kind of conversion to get it from feet to inches. So is there a direct relationship between the number of feet and the number of inches? We all know that how many what are in what? 12.
inches in 1 feet.
There's 12 inches in 1 foot, right? So, we know that 12 inches
360
is to 1 foot. But now, remember, when we're setting this up, the same unit needs to be diagonal from. So, where do we want to put 12 inches and where do we want to put 1 foot compared to our original problem? We want the feet to be where? On the bottom. So let's put 1 foot down here, and then our relationship makes the fraction. So we have 12 inches is to 1 foot. So now if I look diagonally, what happens to my feet? They cross out, right? And what's left over on the top is inches, and that's what we wanted in the first place. Now if it's not what we wanted, that's where we'd have to make up another fraction to figure out how to get it from inches maybe into centimeters or something like that. That makes sense? Okay, so now let's talk about hours and minutes. What's my relationship between hours and minutes? There's 60 minutes in 1 hour, right? So again, 60 minutes and 1 hour go together. So if I look at my original fraction, hours are on the bottom. So when I make my new fraction here, I'm going to scoot this over a little bit. Where does my hours have to go in my new fraction? It's got to be on top because, again, I want them diagonal from each other. So if some of you would have went and said, well, I want to do the hours first, you could have totally done the hours in this fraction would have just been the first one. Okay, so, but what's our relationship? 1 hour and 60 minutes. So each fraction is going to show the relationship between the conversions. It's got to be something. Now, if there's not a direct relationship, then you have to do it multiple times. Okay? So you might have to do it, like I said, 2 or 3 times. Again, most of ours aren't going to be like that, but down the line you'll have to do that, especially, like you said, if you take physics and those kind of things. Alright, so again, if I look diagonally, my hours will cancel each other out. And if I look at just the units, what's left over? On the top, the only thing that's not crossed out is what? Inches. And on the bottom, minutes. And what did we want? Inches per minute, right? So then, once we get what we wanted, we know that we don't have to go any further. But now, don't forget, we got to go back and do what? We got to do the multiplication. Or we can simplify, right? So do you want to multiply straight across or do you want to simplify? All right, what can I simplify? 30 and 60 into what? 1 and 2. Any more? 2 and 12. Any more? 2 and 6. Any more? Now, again, this is where you got to make sure that you understand what you've crossed out and what's left over. Because if some people looked up at there, they might totally be confused. But we've already figured out what our units are for our answer. And then I come back and I say 3 is on the top and what's on the bottom? 1, right? So what does this really mean? Our snail is going what? 3 inches in 1 minute. So if we sat there for a whole day watching that snail, in 1 minute, realistically, that little guy should have went about that far. Right? But you think about it at the beginning. In 2 hours, that snail should have went 30 feet. What's 30 feet? Basically the room. So in 2 hours, it should have went from one wall to the other. Right? So does it make sense when we say 3 inches in 1 minute? Yeah, so basically they're just breaking it down so you can see what it is. All right? Let's try another one of these because these are really important. Turn your book to page 266, please. And on page 266, we want to look at number 12. So try to do this same process with number 12. So in number 12, it says 20 miles per hour, and we want to go to feet per minute. So kind of a lot like the same, but not exactly. All right, so again, start out by showing what you have. 20 miles per 1 hour. And what do we want to get to? Feet per minute. So again, that always helps me to show myself where I'm starting and where I want to finish up. All right, now try it out. See what you get. So again, make a fraction. Whether I'm going to do the miles first or the hours first, make a fraction. And see if there's a direct relationship between where we're starting and where we want to finish. Do I know how many feet there are in a mile? Do I know how many minutes there are in an hour? Now, if you don't, then you got to figure out how many minutes are in something else. Or how many something else are in a mile that you would know about. Or you turn to the back of the book and use those pages in the back. And again, that was on what? 718. Or you can just flip way to the back of your cover too. And then don't forget about how you can reduce. Yeah, remember where we always said that we don't like to have decimals in our answer? This is again one of those places, bless you, that you could have a decimal, because every single time that you do what we would call a unit rate, you want to make sure that this number is always over 1. So even if this ended up being a decimal, go ahead and punch it into your calculator in this case, and just take 5,280 divided by 3. Now, fortunately, it was a whole number anyway. But if it's not, that's where you want to take your time and go ahead and punch it in and get a decimal. How do you do? Do we need to do another one of those kind? Yeah? All right. We'll go back over here. So I think you can do number 13 then in the book.
What was the answer?
Right there. 1,760 feet per minute. So again, sorry, let's look at the end of this one then. Sorry. So again, 20 over 1, I turned into 5,280 over 1, because there's 1 mile is 5,280 feet. That's just, again, one of those things in the back of the book. And then, so again, I noticed that my miles cancel out, and I'm left with feet, and that's what I wanted to end with. So that tells me I was on the right page. Over here, I have hours and minutes. There's 60 minutes in 1 hour. So again, that fraction has to include both of those numbers. And then I cancel out not only my units, and I'm left with feet over minutes like they asked me to, but then I start simplifying everything else, meaning the numbers. So again, I can go up or down or diagonal. All right? So let's try 13. 16 centimeters per second. And what do we want to go to?
Meters per hour.
Meters per hour. All right? So try it again. And again, if you don't know that relationship, use the back of the book. So, is there a relationship between seconds to hours? Could be. Maybe you don't know that, or maybe you don't remember what seconds to hours are. So then you might have to go from seconds to minutes, and then minutes to hours. And that's totally fine. So I'm going to do it this way just to show you, in case you didn't know what that relationship is. So for instance, if I didn't know, or you didn't know, that there was 3,600 seconds in an hour, then I'd have to break it down like this, where I'm showing 60 seconds per minute, and then how many minutes are in 1 hour. But if you notice, if I come back and start crossing things out, my centimeters cross out, my seconds cross out, my minutes cross out, and what's left over? Meters per hour, and I believe that's what we wanted, right? And then I would just have to go back and I would start simplifying. So again, remember, anytime that there's zeros involved, I can just cancel out zeros. It's just like simplifying, right? Let's see, 10 is 5, 3, 5, 12, and then I because everything on the bottom got canceled. So I got 768 meters per hour. How about you? No? Anybody? What'd you get?
Nothing.
You got nothing.
I didn't.
Addie?
I got like 578. I did something.
We'll pick up tomorrow.
I was confused.
I see that.